This talk begins about 3,500 years ago. It begins with something called the cardiocentric theory, and this is a theory sort of popularized by the ancient Egyptians, which sort of stated that the most important organ in the human body was the heart. And the story would go, in fact, actually, they believed it was so important that after they embalmed the dead, the only organ they would leave in this sort of chest cavity was the heart. Everything else would be taken out, put in jars. The heart would be left in, because the story goes that they would cross over and meet up with Anubis, the god of death, and Anubis would sort of measure the weight of the heart against a feather, and if the heart was lighter than the feather, they'd get to go to ancient Egyptian heaven, and if it's heavier, they would get passed over, and the nearest translation we've got is they'd go and meet the destroyer, which is pretty gnarly for ancient Egypt. But they firmly believed the most important organ was the heart, right? And they completely, overlooked a lot of other things, but cut them some slack. It was a while ago. It wasn't for another roughly 1,000 years that Hippocrates sort of proposed the cephalocentric theory. And what this said is maybe it's the brain. It took 1,000 years before they sort of, do you know what I think about this? Imagine how crude the experiments and what's in this? What's in this? We'll call it a brain. Imagine just how rough and ready those operations and experiments were back then. It took 1,000 years before someone proposed this alternative, like maybe the brain's really important. And of course, there's no one organ more important, although we need all of them. But his theory never really caught on. Like for another almost 2,000 years, people were just like, nah, it's the heart. It wasn't until this guy, a British guy called William Harvey in the 1600s, he didn't work out the brain was important, he just worked out the heart wasn't quite as important as we thought. It didn't do as much. It was believed prior to this that the heart controlled emotion, reaction, intelligence, and that was like the seat of, the soul, I guess. So it took a long, long time before we realized just how important sort of the brain was. Hopefully you're seeing this dreadful segue before it comes, because we're about to talk about the importance of what's up here. I am obsessed with head tags. Head tags are possibly the single most important bit of your document when it comes to rendering pages or getting pages on the glass, showing customers websites, basically. Over the next sort of 30 minutes, we're going to learn way more than you ever wanted to know about head tags, just some weird stuff. To do this, we need to start with two key concepts. This is an abridged version of the talk. This is a slightly shorter version, so I'm going to gloss over these key concepts in such a way that you're just going to have to trust me. Two things, I added this slide this morning, which is why it's so pared back. Two things I just want you to keep in mind as we look through these slides and go through this talk. HTML is parsed line by line. I'm going to keep saying this over and over again. I don't have any proofs. Like I say, this is a shorter version of the talk. You're just going to have to believe me. There's no control flow in HTML. It's completely declarative. This is why HTML is fast, because you can parse a partial HTML response. HTML is parsed line by line. If the browser hasn't parsed line 3, it doesn't even know if there is a line 4. It's got no idea. The second thing is the head is the biggest single render blocking part of your page. If it's synchronous and it's in the head, it's going to block the entire page. And your start render is only as fast as the slowest element in your head. The kind of proof of the second point is that because HTML is parsed line by line, and the first thing a user sees is in the body tags, we can't show the body tags until we've parsed the closing head tag. So I guess these kind of prove each other a little bit. So just keep these two in mind as we step through some weird, oddly specific head tag trivia. Apologies. I've got a baseline. I built what I would consider to be the slowest possible head tags, which I realized halfway through is a bit of a redundant task because most of my clients seem to have done this already. That's really rude, but it's true. No, I built what I thought was going to be some purposeful, anti-patterns, some bugs like exploiting or demonstrating some bugs. If you fancy, take a picture of this next slide, and as I'm talking, see if you can spot the anti-patterns as well. So we've got a bunch of stuff on here. We've got cross-site request forgery tokens, we've got style sheets, we've got synchronous JavaScript, we've got JavaScript sort of blocks, inline scripts, we've got CSS with import. This is a fairly innocuous-looking head tag, I would say. There's nothing in here that really leaps out. But I would ask you to poke through it, take a picture, have a look, and see if you can preempt some of the problems we're going to encounter. So this baseline, despite looking relatively innocuous, is really, really, really bad. If you look at a waterfall of this, anyone who's on my workshop will be overly familiar with waterfall charts now. Those 40-odd lines of HTML are an absolute tram smash. This is dreadful. Like, look at the size of that. We don't start rendering until 9.3 seconds. This is a really severe scenario here. And what I'm going to do, or what we're going to do, is we're going to step through all of these anti-patterns, these bugs, these issues, and we're sort of just going to refactor this one by one. Everything in this demo is something that I have seen on a real client website at least once. So it's not just me making weird stuff for the sake of it. This is all real stuff that's affected clients. And what I've done is I've amalgamated all of them to make sort of this Franken head. And we're going to refactor it together. First thing is just trim stuff, get rid of stuff. If it doesn't need to be in the head, get it out of there. Certain things have to live in the head. Your page would break without them. But there's loads of different stuff that we put in the head that could be removed, or there's things we accidentally introduce to the head. So if it doesn't need to be in there, get it out. I'm talking about inefficiencies like redirects. We'll look at a demo shortly of this. We saw it actually in the workshop the other day. Things like redirects, things like certain scripts, like we tend to put stuff in the head. Some things need to be there for the page to work, but imagine a Facebook retargeting async JavaScript snippet growth, right? We don't really want that at all, but our marketing team does. Don't put that in the head. It doesn't need to be there. Move CSS out of the head into the body. Utilize new sort of rendering techniques to free up some of the critical path and start putting CSS in the body tags. So the first thing I'm going to notice or hone in on is a couple of these redirects. And I can guarantee a few of you in the audience are like, Harry, no one's putting redirects in the head tags. No one's that daft. Saw it just the other day. It happens really frequently with specific examples. I can't see my next slide, actually. Yeah, specific examples such as this. If you're using a third-party CDN, it might be convenient to just point at latest. The CDN needs to actually translate that into a fixed version. That's going to immediately incur a redirect. So getting rid of stuff like this can be very, very advantageous. So if we look at the before and after of just getting rid of things like redirects, we've managed to shorten this waterfall down quite a bit. The top waterfall, we incur about 490 milliseconds of redirect time. Stands to reason we should therefore reclaim that when we remove it. So first thing I'm going to tell you is all the numbers I'm going to show you, I haven't massaged any figures. I've been very, very honest. All the tests have been very accurate. But whenever you do any performance testing, you get what's called like a variance. Some things are a bit non-deterministic. So what I found interesting about this is we can see we lost nearly 500 milliseconds to a redirect, but removing it only actually yielded a 41 millisecond improvement in start render. That doesn't mean we leave these redirects in place. We definitely got to get rid of them. But my test showed that actually getting to start render wasn't actually affected that much. That redirect was incurred because we were pointing at this third-party provider. The next thing is just don't do that. Don't point at any third-party CDNs for static assets. The expense is just through the roof. I don't have time in this talk to explain why, but if you want to read in a lot of detail why we don't do this anymore, it's now widely considered an anti-pattern. Just don't do it. Immediately self-hosting those assets is going to buy us a lot more time. So just dragging those assets onto the host domain, we got rid of these redirects. Redirects are, sorry, not redirects, these connections. Connections are relatively expensive to open, and if we don't continue to reuse them, we lose benefits there as well. If you can shove more files over one domain, you can notice things are going to run a lot faster. So there, we actually clawed back 377 milliseconds for a cumulative improvement of 400. To a lot of people in the room, these numbers are going to seem very underwhelming. And to contextualize this, I've got a client back in the UK, and we worked out if we could make their site just 300 milliseconds faster, they'd make an extra £8 million a year. If this was that client, and I just self-hosted a few files and made them an extra £8 million a year, that's a pretty big win, right? I mentioned this in my workshop, actually, but I'm self-employed. This is a bit of a pro tip. Never tell your clients what you did for them. Tell them the outcome of what you did for them. Because I could not submit an invoice saying, oh, I self-hosted your files, give me a 10 grand. So always tell them the outcome of what you did. So self-hosting, this is all trivial, easy stuff. It's going to get more interesting, I promise. Next one, validate your HTML. I know this sounds really archaic and weird. We don't really do this anymore. I don't care about valid HTML for HTML's sake. It can, however, surface some interesting inefficiencies. Invalid head tags can cause real problems, and I see them more often than I would like to admit. There's a really interesting thing about the head. There's a finite, fixed list of elements that are allowed in the head. This is why we hang so many new features off the link tag. The link tag's allowed in the head. If we can't introduce new legal elements to the head tags, because every version of a browser before that introduction would start breaking. This is why we hang things off the link tag, which is pretty interesting. Like, link gets reused for everything. It's because that is allowed in the head already, so we'll just add things to that. If you were to put some invalid HTML or an illegal element inside your head tags, the browser at runtime will do something interesting. You're not allowed inputs in the head, for example. So if the browser encounters this is a common pattern. I see this a lot. It's usually this cross-site request stuff. At runtime, the browser's going to change the DOM. It's going to see this input and panic, and it'll be like, you're not allowed in the head. So it will early terminate the head, open the body just before this input, and push the rest of your head elements into the brand new body tag. It'll do this at runtime. The problem with this is, I mean, everything's still in the right order, but theoretically, we can render the body now. We might encounter a blocking script, so we wouldn't necessarily see anything. But let's say there's a background color red on the body. Theoretically, we'd see just a red page now. So we're going to fix this. We're just going to move that input out of the head. This shouldn't really change anything in the waterfall, because we're not removing any files, but a weird thing happened, which sort of hints at something I'm going to look at later. We ended up losing a request. So we went from 12 to 11. Fixing this helped take the edge off another bug that I'm going to show you, but we'll come back to the explanation now. This actually made the page a bit slower, because we're now putting more in the head, but I would still favor having a slightly slower, predictable code base. Code base, it's only HTML, but you know what I mean. I'd favor like the predictability rather than the speed in this instance. So that got us a little slower, so we're back to about 280 milliseconds. Right. Ooh, right, definitely get your phones ready. I was doing a run-through of this talk this morning. Jet lag's pretty beneficial because I woke up at 6 ready to do a run-through. And I realized that this entire talk, all 93 slides of it, is all hinged around this next just one slide. It just got lost in the rest of the talk. So the optimum head order, there is a theoretically perfect order of your head tags. I'm about to show you it in a second. Get your cameras ready. But that asterisk is just to remind me that this is theoretical purity, and I can't guarantee that you'll refactor your head tags and it will work. You can't just swap CSS files around. We know we can't do that. You can't just swap JS around if it depends on each other. So the next slide is theoretical purity, but it's this. Because this is an abridged talk, I can only go into the stuff that's in white, everything that's gray. I'm going to get out of this photo, actually. Everything that's in gray is going to be missed because it's asynchronous and therefore like largely irrelevant to performance. We've got it. So we're going to look at meta stuff, scripts, everything asynchronous we are going to skip. If you want to talk about any async stuff, let's grab a coffee and we can go over the rest of it. But that's going to be your theoretical fastest head tag. And let's start at the top with meta. Actually, when I did the run-through this morning, I realized I've inverted the first sort of part of this talk, or the first part of the head tags. We're going to deep dive about a specific meta tag, and then bubble up afterwards and talk more generically. Ideally, I would have done it the other way around. This is so oddly specific, but this really happened, and this is a great story. It's not, I mean, it's about meta tags, but it's interesting. Don't invite me to a dinner party. So, CSP, Content Security Policy, that is almost always going to be deployed via a HTTP response header, but you can, if needs be, define your content security policy via the HTTP equiv HTML meta tag. Very rare that you would see that, but it can be done. I wouldn't recommend it because of what we're about to look at. What I need to tell you, oh yeah, it disables the preload scanner. The preload scanner is a fascinating, beautiful bit of sort of just smart thinking. It was actually invented in IE8 by Microsoft. But because corporate, they called it a speculative preparser. Everyone else just calls it a preload scanner. Old browsers were really, really slow. They had one parser, and that parser had to do everything. It had to parse the HTML, discover resources, download resources, and run resources. As soon as any of those resources are synchronous, and basically that just means JavaScript, the browser has to run that JavaScript. While it's running that JavaScript, it can't be looking for or downloading other resources. It makes the web really, really slow. It makes web pages really slow. We lose any parallelization. So IE8, Microsoft IE8, had the idea, what if we design a second inert parser that is just in charge of downloads? So while the primary parser is running code, the secondary parser can whiz ahead and just do downloads completely asynchronously, but then get queued up for the main parser to actually run over. This made the web, I've never found this study again, but it was estimated that the web got about 19% faster because of this invention, like for users. Developers don't need to do anything to take advantage of it. It's just there, and it's amazing. Back in the old days, before the preload scanner, it's parse, discover, download, execute, parse, blah, 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 blah. And you can see there those JavaScript files completely serialized. No parallelization whatsoever. Very, very slow. As soon as the preload scanner turns on, those files are still going to execute in the correct order. It's not going to give us any errors. They can all be downloaded at the same time. You can see the benefit of this. A meta CSP turns this off. So this was a waterfall for a client. You can see that, right? The worst thing is, I'm used to seeing stuff like this. This was a client of mine. They got in touch, and they owned a series of like thousands of sites. They owned like a food blog network. And it's WordPress, and a lot of the WordPress ecosystem talks about server performance by dedicated hosting. So the client was just convinced. The client isn't the domain on screen. My client owned a bunch of them, so it's not this company's fault. They were convinced, like, what's WordPress, it's a server thing. They were spending an eye-watering amount of money on hosting trying to make this site faster. As soon as I look at this waterfall, I see some pretty interesting things. That vertical green line, way over towards sort of the right, that is start render. If start render's that late, their problem is in their head tags. Easy as that to work out. If we're not rendering the page, we've not got to the body yet, right? Easy to work out. What I noticed, though, is we've got a lot of parallelization with this CSS, and then as soon as we start to hit these different domains, if you see there's like green, orange, purple, that's different domains, these third parties start to drag the waterfall out. Everything's looking a bit sequential, a bit serialized. There's a lot of mess here. So my initial instinct is, right, some third parties are just ruining performance. So I reran the test, cutting all third-party requests out, expecting to see a return to normal. Got the opposite. It actually highlighted the problem really clearly. This is a very unusual phenomenon. Seeing this is very strange. My first thought was, well, maybe each JavaScript's injecting the next one. But the problem with that, or the reason that theory fell down is injected JavaScript is by definition asynchronous. So requests after this block shouldn't be held up. They're asynchronous. Then I thought, hang on, this is like IE7 era. I was like, I think the preload scanner's turned off. I think the preload scanner's gone. I don't know why. I couldn't fathom why this might be, but it was my sort of instinct. So I did the only thing that was really left, is I just viewed source and read every line of their head tags for anything fishy. Found this. This itself isn't weird, but seeing it in the middle of a head tag, so I was like, well, that's got to be something to do with it. So just using some local overrides, I managed to move this to the top of the head and found out that, yeah, this was the problem. If you move this to the very first thing in the head, everything's done in parallel. I had no idea why this was happening, so I just went and read the preload scanner source code, and it literally says, don't preload anything if we find a meta CSP. I still don't know why they do this, But moving it to the top of the head before any requests gives you the preload scanner back. Ooh, that was smooth, wasn't it? That smooth bit is getting quoted by Toby as well. I know that now. Fuck. Be good to me, Toby. A mate of mine, Tune the Web, Barry Pollard, much smarter than I am. I asked him to do me a favor. I was like, can you just go and find how many web pages, not even sites, pages on the internet suffer this problem of a mid-head CSP? It's a really small number. I've used this clicker at every talk for 10 years, and I just killed it. Rip. Oh. Come on. 8,500 pages, like very few pages actually suffer this. Most of those 8,500 were probably my client. Moving that meta tag to the top of the head completely mooted this problem. Basically what they'd done is they'd made a little checkbox in their sort of big WordPress meta install. Would you like to enable CSP? And their developer had naively, but I wouldn't blame them, just said, yeah, if they've enabled it, put it here, and they just put it in the middle of the head. We'll move that if statement to the top. Everyone who'd opted into extra security, the site just got so much faster. So yeah, this is what the effect on the waterfall was. We've got our parallelization back. We've also managed to lose a few requests, and this goes back to what I was saying about the invalid head tags. We've got some extra requests here. If you put a meta CSP like in the middle of the head, all the files that were requested before that meta CSP was parsed need to be discarded because they're potentially insecure, right, or potentially violate it. So we got a load of double downloads. After this CSP was discovered, the browser had to go and re-download a load of stuff. This change alone, on my demo at least, 3.7 second improvement for a cumulative 3.9, sort of 4-second improvement. We're going to bubble up now and talk about metadata about the page. Those 2 asterisks are for me to tell you this isn't like SEO or like Open Graph meta. This is metadata about the page. Stuff about how the page should be dealt with. So we're talking meta viewport, we're talking character encoding. Get these in front of the parser nice and early. The reason for this is, let's imagine you've got, most browsers are UTF-8, right? And let's imagine for some reason you've got a page that's ANSI. If you were to put your meta character encoding halfway down the page, the browser is going to start parsing it as UTF-8, find an ANSI character encoding and be like, oh, and I'll have to go and reparse the whole page again with a different character encoding. So the spec even tells you, just get it in the first kilobyte of uncompressed HTML. The other thing is your meta viewport. HTML is parsed line by line. So if you were to put your meta viewport near the closing body tag, that's meant to play. Imagine what would happen. Oh, it's playing. It doesn't play on my screen. You see what happened there? The browser sort of didn't know the page was meant to be responsive and did a zoomed out desktop version, then found the meta tag at the closing body, had to repaint the whole page. Now, no one would ever put their meta viewport outside their head. I can't imagine anyone would do that. Technically, it doesn't matter where in the head it goes, because we aren't starting to render. If we're still inside the head, you could put your meta viewport very last, but just it's easier to think. Anything that tells the browser how to deal with this page, get it in front of the parser as soon as you can. That includes the title tag. The title tag can often be a visitor's very first experience impression with your site. HTML is parsed line by line. 3 of you listened. Yeah, so if we had a bit of HTML like this, we had a slow script, let's say that script takes 2 seconds to download and execute. The browser doesn't even know the page has a title yet, because it can't find it, doesn't know line 4 exists. About to play a little screen recording. Keep an eye on Chrome's tab. No page, no title, it's just a URL. That was only like a 2-second delay. If this file was timing out, it would be 80 seconds. By putting anything synchronous in front of the title, we're hiding it from the browser. Watch what happens next. And what happens next, if we simply swap these 2 around, is the browser can immediately throw the title into the browser Chrome, and the script comes next. So you're immediately going to get some feedback that the page is working. We haven't rendered it yet. We have now. Dead simple, do that. I've had clients with really expensive third-party scripts, like Optimizely, something that's quite heavy, blocking third-party. That ahead of the title, it can hide that bit of browser UI for several seconds at a time. It's just not a nice experience, especially when it's that easy to fix. Interestingly, while predictably this didn't change the shape of the waterfall, reordering metadata did have a performance improvement. And I promise you, and if you're interested, I'll explain my methodology. I'm not massaging any figures. 280 millisecond improvement just by sorting out metadata. And that was the average, or the median of 5 tests. I did my due diligence. So yeah, there's that. Now it's about to get interesting. This next bit really freaks developers out. Put your JS before your CSS. Every developer tends to think the opposite. Like, no, styles are blocking rendering. We should put CSS nice and early. There's a really interesting phenomenon. Synchronous JS, where possible, needs to go before synchronous CSS. That's because CSS blocks the execution of subsequent JavaScript. Synchronous JavaScript will not run if there is any CSS in flight. And the reason is, it's quite simple, but very defensive. And I would posit that 95, 99 times out of 100, we do not need this defensive behavior. A browser won't know what a script is going to run until it's run it. The script could be asking CSS questions. So what that means, if we had a snippet of HTML like this, if we were to do this asynchronously, that script runs, we've got a race condition. That script could return a stale value, an incorrect value. It could return a correct value. But more likely than not, it's going to return an incorrect value. So the browser will purposefully hold off running that script while CSS is in flight, just in case the JS asks a CSS question. This is an example for example's sake. A more compelling example of this being problematic would be something like this. You see this a lot in third-party scripts. Paste this in, it'll asynchronously load your JavaScript. That script block is an anti-pattern nowadays anyway. This is just a polyfill for missing async attribute support. We've had that attribute for a long, long time. So we are finding third parties move away from this pattern. But those that do still use it, what's going to happen with this format, CSS first, is a waterfall like that. Complete serialization. The browser wasn't able to run that script until it finished the CSS. If that script was of any importance at all, we've delayed it by however long we waited for CSS, unnecessarily. So, simple fix here. Just going to swap those around. And now we get complete parallelization. The CSS is still discovered first, therefore requested first, but the JavaScript is now fully parallelized. I find this really interesting because Google Analytics and Tag Manager, etc., they tell you, and a lot of third parties tell you, put this at the top of your head. Put this script as close to the top of the head as you can get away with. And most developers are like, piss off, I'm not doing that. Who do you think I am? You're going near the bottom. This is correct. They're not doing this for nefarious data capture reasons. They're trying to help you keep your site fast. There's a slight caveat. Synchronous JavaScript blocks CSS that's imported. If you've got CSS that is at imported, that file needs to go before the JavaScript. Now, you're probably thinking, this is a lot to juggle. Don't worry, I've got like a thing at the end that will help you not need to memorize this. But this is an interesting behavior. It's a behavior in sort of Chromium browsers. It's not in Firefox. It is in WebKit because it's forked. Well, Chromium is forked from it. That little dagger is to remind me to tell you that depending on your point of view, this is either a feature or a bug. When I raised a bug with Chrome about it, and they realized it would be a lot of work to fix, they decided it was a feature and it's going to stay. Basically, something really interesting. We've got a synchronous JavaScript file on line 3, and right after it, we've got a CSS file that contains an at import rule. What's going to happen here is we're going to get a waterfall like this. Start renders 4.7 seconds. What's very strange is that CSS looks as though it was requested by the JavaScript. Looking at that waterfall, the CSS is right pegged on the end of the JavaScript. We know for a fact that CSS came out of this file. Why did we have to wait for it to be requested? Well, browsers are single-threaded. They can only do one thing at once. And tasks, are things like script, recalc style, layout, paint, composite. Right? Cassie told us that yesterday, right? These are the things that browsers do, and they have to be done synchronously. So what's going to happen is the browser is going to download the CSS and then have a synchronous script right after it, and the browser is now in scripting mode, and we can't interrupt it. In order for the browser to discover that at import, it has to do a recalc style task on the first CSS file. It can't do a recalc style until it's finished the script, and if that script takes n seconds, that's how long we have to wait before we can recalc style the CSS to find the import. This is simply because there is no preload scanner in CSS. Firefox has one, Chromium doesn't, so we have to wait for that JS to run before we can, excuse me, even begin to parse and recalc style that first file. Switching this around, we're going to get a much nicer waterfall. There we go, parallelization again. So if your CSS file contains @import, that does go before your JavaScript. All other CSS files after your JavaScript. Start render is now 2.9 seconds. This is bizarre. This is the Vans Canada website. They're not a client of mine, but their head tags are enormous. If you look at this waterfall, we're going to see that their head tags are 144 entries long, 144 requests out of their head tags. Line 100 @import entry 144. But between it was loads of JavaScript, and that JavaScript gets queued up, takes a very long time to download, it's getting dragged out, there's lots of network contention. We had to run all of these scripts in between before we could recalc that style, style sheet way further up the stack. 9.3 seconds we waited to import that file. That pushed start render back 9.3 seconds. I haven't checked it for a while, but I did open a bug with Chrome about this. Not sure what the situation is at the moment. But if we rejig our JavaScript CSS to follow these patterns, we see, again, like really, really good impact. That inline script now runs immediately after the HTML is downloaded. If you look at the first entry, we've moved that before any blocking style sheets. And we've now got some parallelization by making sure the import isn't stuck behind JavaScript either. The benefits of just rejigging a few lines of script and style, we're looking at a 1.65 second improvement for a cumulative 6-second overall improvement. All right, yeah, the next thing is don't use import anyway, just don't use it. Import is really bad for performance. It offers very, very, very little benefit to anyone. If you want to know why, you can go and hit this URL, and I go into way too much detail. So what I thought is just for bonus points, let's get rid of the import anyway. Let's just put another link rel equals style sheet. You may be using certain third parties, usually font providers. They still use import, which is really irresponsible of them. But where you control it, don't use import. By removing it, we now move to complete parallelization. This has bought us another 3/4 of a second. I'm running out of time, so I'm going to gloss over the next bit fairly quickly, but if you're going to get kickback from your SEO or marketing team, these next few slides are for you. Put all your SEO and social, put that last. Like, it's asynchronous, so it doesn't necessarily matter where it goes. Stick it at the end. I do get a lot of SEOs telling me, oh, but if I put all my meta tags and my open graph stuff near the closing head tag, Googlebot might not find it. Here's the thing, as we know, HTML is parsed line by line. Googlebot is a browser. If Googlebot can't find the end of your head tags, it can't find the start of your body tags. You've got way more to worry about than your meta tags. If Googlebot hasn't made it to your body, you're not going to be getting anything indexed. So that's a little get out of jail free card. Nope, not how it works, because browsers don't work that way. Okay, a new order if you want to see the refactored code. It's not that exciting, but there's a GitHub repo there. We basically got first contentful paint down to 2.7 seconds. I'll flick that back if anyone wants the URL, actually. We've bought a lot of time there. I didn't refactor onto a new JavaScript framework. I didn't re-architect anything on the back end. I didn't do anything complex here. Just knowing how browser internals work and the quirks involved, we just nudged some lines of HTML around and had a massive impact on performance. And I can't stress this enough. Each of these examples I have seen on real sites at least once. The CSP, I sort of saw it once on thousands of sites, but everything else is quite commonplace. The blocking JavaScript, the import stuff, it's probably on a bunch of your sites too. And I'd just be keen to make you aware, go and squish it. This is the new order of the HTML. It's roughly the same size as before, way, way faster. All right, oh yeah, and if we look at the waterfalls before and after, just nudging lines of HTML around, you can see immediately the benefit, how much neater this is. This is why I'm obsessed with head tags as well, because it's just kind of fiddly and fun, and I don't know, it's kind of cool getting this much benefit, this much advantage out of a small part of the page that weirdly a customer never even sees. This is the only invisible part of the page. Oh, right, so I've mentioned before, there's a lot of stuff to sort of memorize there. I'm a nerd, and it's my job to do this, so I have memorized it, but I don't expect anyone in this room to memorize it too. So just for fun, I was thinking, this is basically a really lame arc, so I can talk about medical stuff that I know nothing about again. Computed tomography, right? A CT scan. I'm bad enough at riding bikes that I've had a few of these in my time. It's a really quick way of just looking inside someone's head. So a few months ago, I had the idea I could build like a thing that's like a CT scan for a web page. And fairly foolishly, I built it in CSS. Just because I used to write CSS like a million years ago, I thought this would be quite a fun thing to do. So yeah, you can grab this. I'll share a link in a second. Add ct.css to your project, and it will show you stuff like this. We've got an inline script. That's a green flag. We've got an async attribute on an inline script. That's redundant. And it will just tell you what to do. It will tell you, move these around. Green is good. Green is either asynchronous or inline. I'm a pedant. I'm really pedantic. Inline script and inline styles are still synchronous. They're still render blocking. So when people say, oh, we've got no render blocking assets, you do, it's just in the HTML. But they're green, they're fast. The color is the severity. If it's a solid line, it means this is the focus of your attention. If it's a dotted line, it is this file is affected by another file. So I can work out where the problems are fairly quickly. The CNN website broke the tool. I was picking on CNN on Monday as well. It's too easy. If you want to use that tool, it's right there. So please go ahead, grab a picture of that if you want. You can add it to your project. I'll move out the way again. Toby was showing me this stuff earlier. It is mad how much stuff he's got going on here. Yeah, so that is CTCSS. Add it to your project. It will quickly allow you to proxy the problems, see what you need to reorder, and just keep sort of tweaking your HTML until everything goes green. There'll be some things you can't get around, some things you can't avoid. Like I said, this is fairly theoretical purity. But it's a huge part of my working life is just assessing clients' head tags, making sure they're as sort of tight and as neat as they can be. And as we've seen, like for the right clients, it can make a huge difference. Last thing I'm going to say before I say thank you, pretty gross bit of self-promotion, but on Monday I released a new DevTools video course, and there's just a link there with a discount code for you folk. If you want to take a picture of that, feel free. With that said, I feel very frantic, and I can hear myself. The speakers, I'm freaking out. But yeah, I just want to thank you for your time, and yeah, you've been great. If you've got any questions about the stuff we didn't get to cover, like the async stuff, grab me on one of the breaks, but thank you very much for your time. Have we got time for questions, or have I?
Time? We've got time for a few questions, but you can chill now. Nice. Thank you very much.
Yeah.
I'm going to perch on the end next to you. Is that all right?
That's absolutely fine.
Well, so first of all, ct.css, genius naming, and that's a lovely resource. Have you started using that as a tool for your own quick way to assess things?
When you go to that URL, and remember bookmarklets, you can just drag and drop a bookmarklet to your browser and click it, and any page you're on, it'll just show you the head tags.
Oh, I love it. That's fantastic. I really like the fact that you can get a quick audit and then start making improvements really quickly. So I'm curious. You've seen a lot. You've done a lot of these kind of bits of analysis now, and you've seen a whole load of different sites, loads of examples. My instinct is that you might encounter some common foes, like some regular culprits. Is there one in particular that you always think, first things first, let's just go and see if this little fella's here? Is there one regular culprit, or is it usually a combination of things?
The really sort of controversial thing would be like, yeah, React. But no, it's generally going to be people not self-hosting their assets, like just really things that are the easiest to fix, and it's like, that's going to take you 3 minutes,
Right.
less than, and it's going to get you hundreds of milliseconds. So that's probably the single most common thing when we're looking at head tag kind of stuff.
Yeah.
But then more broadly speaking, yeah, JavaScript is still a huge problem because JavaScript is kind of slow by default. We love HTML. HTML's fast. So I see things like people building their largest contentful paint candidate in JavaScript, which is always going to be slower because you've got to download the HTML and then some JavaScript. It has to run successfully, then put your LCP in the DOM, then you get a paint.
Yeah.
Just favor HTML wherever you can.
Favor HTML wherever you can. Oh, I'm tempted to give you a hug, but that's speaking to my heart. So one of the questions that came in as well is like trying to weigh up which thing to optimize for first. So content layout shift versus optimized page speed. Is there, like, would you focus in which is more important to solve, do you think?
As in CLS, do we think? Is that?
Yeah.
Yeah. Page speed.
Page speed.
Yeah. Well, CLS is not a speed metric anyway, so it's kind of not dissing the question.
It's an experience,
just a bit of
though, right? It's an experience.
It is.
Yeah.
But I've been doing web perf since before Vitals were a thing, and case studies, all case studies have shown that faster sites convert more, make more, cheaper to run.
Yeah.
So yeah, I mean, did you want me to say CLS? Good. 'Cause it's site speed.
No.
Speed
if that's
first.
the answer, that's the answer.
And it also depends if you're optimizing for SEO or conversions. If you're optimizing for SEO, it's obviously all three of your vitals. But yeah, I would always look at speed before I look at layout shifts.
Fair enough, yeah. And I quite like the fact that through things like Lighthouse audits, it feels like there's a bit of a culture of we should try and get those 400s, get those nice green circles. Are there cases where just solving for that and then thinking we're done is bad because you're overlooking a lot of other things, or is it a really good place to start and just be saying, you know what, go for the 400s and then you're going to be in good shape?
So I think I'm very fond of Lighthouse for what it did to democratize web perf. You know, people can discuss it within the business now. But optimizing the numbers for the sake of it is a little naive because your user doesn't see those numbers.
Right.
In an ideal world, you'd be tracking things like how much does a slowdown impact conversion rates.
Yeah.
Because you might have a 97, but your site is the most profitable it's been in terms of web perf. You might miss a couple of daft things with image dimensions, and it might drop you away from 100, but you're still making loads of money.
Yeah.
So yeah, I think Lighthouse is great for benchmarking yourselves internally.
Yeah.
No one realistically cares what numbers you've got. As in, a user doesn't see them.
Yeah.
They don't count
It's
towards
the
your vitals
experience,
SEO.
the result, yeah.
So if you can get 400s, definitely. I just fear that Google years ago said, oh yeah, well, sites need to load in 3 seconds. And then engineering teams were told, oh yeah, we need all these ads, these carousels, and the 3-second thing. Now I feel that it's just a 4/100s thing. And engineers are just being like benchmarked by that.
Nice. Okay, that's great. We're almost out of time, but I do want to ask you: have you ever been to? And this is the circle of trust, right? Everyone went. I mean, there is no live stream really. No, it's just us. Sorry, live stream people.
Oh God, what's going on?
No, I'm just curious. And would you ever admit? Have you ever been working with a client where they said, right, we've got some issues, and you kind of open the hood, look inside, and go, has the mask ever slipped? Have you ever gone, oh, crap, okay, we've got a lot of work to do here? Have you ever slipped like that?
Well, not slipped, but absolutely. I've looked at sites and started paring things back and being like, oh, God, this is actually really bad.
Yeah.
I just tell clients, look, what I'm going to do is I'm going to do a first sweep, deploy that, we need to clear the weeds, and then we'll go again.
Yeah.
it's very rare. Most things, especially I've been doing this for long enough now, I can spot them, and doesn't matter how much there is, you can always just tick them off. There's one particular project where I was like, we are going to need to do this again. Then come back around. We'll get the stuff cleared so we can see the problems better. And that was recent, actually. That was this year.
Okay. But then you're off into making progress, and they're seeing results, and everyone's a winner.
Yeah. It was like one of those things where I kind of wanted to say, just rebuild it all.
Just
probably would be quicker.
Rebuild it all.
But obviously that's untenable.
Yeah,
So,
yeah. Fantastic. Okay, well, thank you so much, Harry. I wasn't quick enough to see the promo code for your workshop.
I've spammed them enough.
You've spammed it enough. Oh, well, people can find you around the conference and ask you more questions, and there are workshops on the way and all those kind of things. So
yes, I'll be the very warm English boy. If you need anything, come and find me. But yeah, I've had a wonderful time.
Super.
Thank you, everyone.
Thanks everyone so much, everyone. Harry Roberts.
Thank you.
Thanks, Harry.